Hello, so we are looking at a medium question today, 1302, deepest leaves sum. Basically, given a root of a binary tree, we are supposed to return the sum of values of its deepest leaves. So we only want the values of the deepest leaves summed and returned to us, right? Okay, now let us start with a whiteboard. I'm sorry about the plain sound. It's National Day today, so yeah. Okay, where's my pen? Alright. So let's copy this tree over. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, perfect. What we want to do is add up, return this one and this one, add, and it gives us 15. We want to return 15. Okay, again, sounds like a recursion problem again. We only want to add the deepest leaves only. So we don't want to add 5 because it's on level 1, 2, 3, right? We only want to add 7 and 8 because it's on the deepest levels, which is level 4. So we can make use of our get deepest level function, which has been gone through in I think 1 or 2 videos ago. So watch that if you haven't already. I'm just gonna watch previous video. Okay, so once we have this return 4 in this case, right? Once we have this return, we want to plug in this deepest level and then check if at level 4 if leaf node we want to add to total sum. Okay, take note of how many variables there are. We have this total sum, we have this level we need to pass in, right? So the recursion, when we think of recursion, we can think of temporary boxes that we want to hold unknown values yet, right? So we're gonna do something like this box. Okay, no, not the leaf value, that's fine, we move on. This box question, don't know what it's gonna be, and then this box again, non-terminating yet cause it's not a leaf. Okay, and then we reach this one. We know that this is 7 because it fulfills this condition, right? It fulfills this condition, so we return 8 over here, 7 over here. We return it recursively up the tree. It's like kind of like copying it up the tree. 7. This one we turn nothing. We don't, because it doesn't fulfill the at level 4 condition. Return it up the tree, return up the tree, return up the tree, and at this point in time we need to add on 7 and 8. We get 15. So our recursion statement, what do we need to do? for our recursion statement, what we need to do is figure out a way to add this left subtree and the right subtree. So we just call this function myfunc. This is the terminating condition. Our recursive condition will be something like myfunc left side. We need to pass in left side. We need to pass in deepest level -1, because we traverse the level, we need to -1. And then total sum. Add this with, because remember at this point in time we need to add it, myfunc right side deepest level -1 total sum. Okay, so yeah, and don't forget about the null check. If not node, basically if it's an empty, if it's a null node, we want to return 0. Okay, perfect. Let us exit drawing, go back to the question and start coding. Okay, first off, we want to get the deepest level. Deepest level is, we call a function self.get deepest level, pass in the root. Let's define that. I'm not gonna discuss how to come up with this deepest level question. I think I just uploaded it like a couple of hours ago, so watch that if you haven't already. Yeah, okay, root. What do I want to do? Let me think. Brain pausing moment right here. Get deepest level. How do you get deepest level? Okay, we start off with the if root is none, return 0. Root dot left is none and root dot right is none. Return 1. Return self dot get deepest level. What do I want to do? Root dot left. Oh, we need to find the maximum of this too. Oops. +1. +1. Okay, that should return us the maximum level, and with that we want to pass in return get deepest leaves sum. Okay, so let's define, forgot the self dot, very important, def self get deepest leaves sum, pass in self root. What do we need? Just now we discussed that we need total sum and the deepest level as well, right? Deepest level and total sum. Terminating condition, if root is none, return 0. If root dot left is none, root dot right is none. We need another check. If deepest level equals to 1, then total sum plus equals to root.val, return total sum. Finally, we want to return self.get deepest leave sum, pass in root.left deepest level -1 total sum plus root self.get deepest leave sum root.right deepest level -1 total sum. Yeah, we okay, so let's pass in the parameter arguments. Yeah, arguments. We go root deepest level and total sum, we start from 0. Okay, so deepest level we go 1 instead of 0 because this we consider it 1 level, 2 level, 3 level, 4 level. The levels are not 0 indexed, so we make sure that we don't forget about that and we do deepest level is to 1. Okay. Alright, so looks like it works. Thank you for watching this video.